Hello out there dear friends, and welcome to this video today. In this video friends, we shall be looking at how we can show that the volume of the cone we have here is the same like 1/3 pi r squared times the height. So friends, as you can see, we are going to be using calculus to show this. So friends, please, for a quick reminder, if you're new to this channel, don't forget to hit that subscribe button and press the notification icon to get notified each time you upload new contents. And please don't forget to like the video, because it does motivate us enough to keep producing more good contents for you. Thank you very much indeed, and please share it out with your friends so they can have access to good contents like this. Thank you very much, because guys, this question keeps coming always and always in the calculus exam, guys, and I don't want more students to keep failing. That's why I've decided to produce the solution to this problem today. So guys, let's get started. So friends, in order for us to prove that volume using calculus, we are going to start by bringing forth a curve. Okay, let's have the curve of this form. Let's call it y. Then we have the horizontal line, because the vertical line was called y. The horizontal line, or the horizontal axis, we can call it x. Good. So friends, we are now going to have our origin. Then we have a curve of this form. We have a curve of this form, guys, of which the x value of that curve is r. Then the y value at this point, guys, it is okay. Then the height of this our curve, the height, that is the vertical distance from the origin to the point where it touches the y-axis. We have it as h. Good. So friends, now if the coordinates of this point at the point r, right, is going to be x. It's going to be x comma y. Our x is what? R. Our y is what? 0. So we have it to be r comma 0. Then now friends, at this point where it touches the y-axis, at this point our x is what? 0, and our y is h. Good. So that this is the h value. Good. So friends, at this point in time now, we are going to start by getting the slope of this straight line. Okay, just know that for us to be able to produce a cone in this Cartesian plane, we are going to rotate this curve about the y-axis, because after rotating we see a solid which is going to be generated, and that solid is going to be the cone. We are going to compute the volume of that solid, and it's going to give us the volume of the cone that we are looking for. So we'll start by looking for the slope of this straight line, because we need the equation of this line. Okay, we need the equation of this line, so we have to start by getting the slope. So the slope, as you all know, it is what? Change in y over change in x. So in this case, it will be y0. It will be y0 minus x0 over it will be y0. That's y1 over y0 other than x1 minus x0. But our y1 is what? H. So as we're going to have our slope m to be h minus 0 ordered over 0 minus r. Good. So in this case, we are going to have our m to be negative h over r. Good. So friends, this is the slope of this line, negative h over r. Good. Then now friends, we are now going to write down the equation of the line. We know that the equation has general form y equal to mx plus c, but in this case our c is the y-intercept, which is going to keep giving us what? H. Good. But our m, guys, what is our m? Our m is negative h over r. So we are simply going to have the equation to be y equal to negative h over r x plus h. Good, because of this x. So this is the equation of the curve in which we have, of the line in which we have. Good. So friends, now all we'll start by doing now is that we are going to rotate the curve about the y-axis. Okay, after rotating now, guys, we are going to see the curve in this form. Why? Because if you rotate this curve about the y-axis like this, it is going to appear to be of this form, and the solid and the volume of the solid generated, guys, is going to give us our cone. Right? Good. So after rotating it about the y-axis, we are going to produce this solid, as you can see, and the solid is a cone. So let's put some calibrations. We have this other part where this guy comes and rests is negative r. Then friends, we are going to use the disk to estimate the volume of this cone. Okay, so I have a disk here. I have a small disk here, guys. It's just an estimated disk. We're going to look for the area of this disk, and we simply just add them up. Okay, now this disk has a certain y value, right? Because we've simply partitioned our cone into smaller disks. which all have a change y value as dy. Okay, that's the small change in the y value above. So now each of these cones that we've produced, each of these discs that we've produced using this our cone is going to have some small y value to be what? Dy. Good. So friends, we can now go forward now to set up our integrals, because guys, we know that when the curve is being rotated about the y-axis, the volume of the solid generated is given as the integral from 0 to h of pi x squared dy. Now friends, you notice that these are the y values, right? Keep in mind that we are in the y world. That's why we have dy. Then the limits of integrations must be y values, so we have it from 0 to h. Good. Then we have of pi x squared dx. Good. And friends, the reason for putting this pi x squared is that we know that this disc has the form of a cylinder, right? Has the form of a cylinder, and the area of a cylinder is simply given as what, guys? Great. It's simply given as pi radius. That's the pi x squared, or the pi radius squared. Good. So that's how we have it. Then now we are going to sum up all of them. We are going to sum up everything, guys. That's why we now have our v to be the integral from 0 to h of pi x squared dy. Good. But friends, keep in mind that we are in the y world, and x is not invited in the y world. So we are going to make x the subject of this our formula. By making x the subject, guys, we are going to have our x in this case to be the same like r into h minus y other than h. Good. If you make x the subject here, because we are in the y world, x is not allowed. So if we make x the subject here, we're going to have this as we have. So we simply bring it back to the equation and substitute. We're going to have our v to be the same like the integral from 0 to h. This pi comes outside. Our x is what we have here, everything squared dy. Good. Then now friends, in this case now we are going to distribute the square. We are going to distribute the square in this arrow and in this h. So we're simply going to have the integral going from 0 to h of h minus y all that squared. Keep in mind that this square has squared this arrow to give us arrow squared. That's why we have it here. Then the square has squared this h to give us h squared in the denominator. That's why we have it here. Good. So friends, at this point in time now, you could decide to expand this whole function and get the integral done. But in that case, guys, I don't think I will do so. I won't do so, guys. I'll rather do a suitable substitution. I'll do a u sub, friends. I'll do a u sub. I'll let my u to inside. The inside is what? H minus y, such that du gives me what, guys? Gives me negative dy. Good. So now I can now take the integral from the y world now to the u world. And guys, you see that these are the y values, right? 0 to h, the y values. When y becomes 0, our h becomes what? Our u becomes h, right? And when y becomes negative, and when y becomes h, sorry, u becomes 0. Good. So we are now going to have now the integral going from h now to 0 of this negative, guys, are simply come ahead, okay, come outside of the integral. Good. And first, integrating this guy now simply gives us just positive now, pi r squared over h squared. The integral of u squared du, guys, we add 1 to the power and 0 by the new power. We are going to have 1/3 u cubed. The limits are going to be from 0 to we're going to have from 0 to h. It is not from 0 to h now, because here was from h to 0, but it was negative, so the negative has taken care of the limit. So we have switched the limits using the negative sign. It's super important, guys. So in this case now we are going to put in our values. We start from the upper limit minus lower limits. The upper limit, guys, we are going to have our v to be this pi r squared h squared is here. Then we have 1/3 into we have h cubed now minus 0 cubed, because it's upper limit minus lower limit. So if we simplify now, this is just going to be h cubed. 2 of the h, we cancel 2 of the h here, guys. We are simply just going to have v equal to pi r squared over 3h. Good. Times the same our h that we have here. Oops, guys, I'm sorry, this is supposed to be h, okay? Then this guy is supposed to be This is not supposed to be here again, friends. I'm so sorry. This h squared is not supposed to be here. It's not supposed to be here because this is going to cancel with one of them here. Okay, good. So if we do it so now, we are going to have our value v to be something like 1/3 pi r squared coming out. Great. So friends, don't forget to like the video, friends, because it does motivate me. It tells me that you found the content so useful, and please share it out with others so that they can have access to good content like this, guys. Thank you very much for watching the video. See you in my next video. Stay safe, guys, and have a blessed